The prototype PCBs have arrived. I sneakily added a few additional features. There are some test points on the board. This is going to help us with commissioning the circuit. It helps to assemble small parts of the circuit like the power supply part before moving on. That way we know that our power supply is stable before we go on and build the rest of the circuit, just in case there's any problems. Helps us narrow down where any problems might be. If this is your first time soldering, this is a pretty unusual way to do things because we're starting with surface mount parts on the power supply section. If you have no interest in doing surface mount soldering, because it is a little bit harder, you can attempt to assemble the signal generator section and then just power the signal generator section directly from a 5-volt power supply. And you can do that through TP2, that is the 5-volt test point. TP3 is the ground test point. For commissioning this circuit though, I'm going to assemble all the surface mount stuff first and test the power supply works before moving on to the signal generator part. I've got my safeties on, my soldering iron is set for an appropriate temperature for the solder that I'm working with. Let's get started. In general, we start with the smallest parts first, which is why I'm starting with the surface mount parts. Everything here is quite spread out though, so it's not a big deal. D2 is the Polarity protection diode, and I'll just drop the diode straight next to its footprint and orientate it. That way I can charge the pad with solder, wait for that solder to wet, and then I can bring this over while the solder is still liquid and create that join. That way I know the part is sitting flat on the board. If you're unsure, you can always press lightly and then remelt the joint. And for this second join, I'm going to heat both the pad and the component lead and feed the solder in at the join. And we're looking for nicely wetted fillets here. We can see that fillet is shiny and silver and nice and smooth between the pad and the part. This is a polarized component, of course, so the stripe on the part is on the same side as the silk screen artwork for diodes. The 12-volt power indicator LED, D3. This part has a notch that points in the direction of the more negative side of the diode, just like D2 had that stripe feature. So I'll line that part up near its pad and do the same thing again. Charge that pad with solder, heat the pad, and then bring the part into the join. Keep your iron clean. And proceed. R3 is next. Don't be afraid to retouch existing joins, especially if you were heating them for a long time. Touching a little bit more solder in can introduce some more flux, which can help create that clean join. That was the capacitor C3. Now for the voltage regulator U2. This large tab is going to require a lot more heat, so just be patient with it and let that solder wet nicely across the whole tab. That helps to create a thermal bond so that the heat created by the regulator can be absorbed by the surrounding board. So the regulator is pretty much done. I will just put in that 5-volt indicator LED, which is D4, and its matching resistor R4 before testing the circuit. The 5mm through-hole red LED has a long lead for the more positive side, and this flat edge aligns with the flat edge on the silkscreen artwork. I'll just bend the leads underneath to keep that in place. The footprint we chose for this resistor means that the bend will be very tight against the body of the resistor. It helps to pre-bend the leads and then feed them in one at a time. As that resistor gets closer, you may have to pinch the leads to get it seated. Flip the board and bend those leads so the components stay in place, and solder each lead. I'm heating these through-hole joins until I can see the solder is being drawn into the through-hole. It's wetting all the way through. This pin that connects to ground with these little spokes, it connects to this ground fill, it's going to require a lot more heat because the ground plane is going to absorb a lot of that heat. So just be patient with pins connecting to ground. You can see the solder kind of wants to stick because the join is resisting heating. But just be patient with it. Take side cutters. I like to cut these just at the top of the join, and I keep a finger on the lead so that it doesn't fly away. For convenience, I'll also fit J2, the 2-pin terminal block, so I can power this board. This is a little trickier to solder. Tin the iron with a bit of solder and just tack one of the leads in place. Just enough. It doesn't have to be a great join, just enough so it doesn't fall out. Then while that tack is holding, we'll solder the other pin. I'm using the side of the iron to make a big contact patch and get a lot of heat into this join. Wait for that to set, and then solder the tacked pin properly. And I waited there until I saw that solder kind of pop into place on the joint. That's wetting correctly. I've connected my circuit to a power supply that's set for 9 volts and about 0.2 amps. Not too little so that the circuit isn't going to work, but not too high that anything's really going to get damaged if there's a problem. I'm mounted up in the panel vise as well, but I've made sure that the metal parts of the vise aren't touching multiple nets. There's no shorting being introduced by the jaws of the vise. I'll apply power the moment of truth, and I have 2 LEDs on, so there's at least something happening on the board. My 12-volt LED is lit, so that means that there must be power coming in on the input side. The diode is around the right way at least, and our wires are around the right way. And I have the output 5-volt LED lit. That doesn't necessarily mean there's 5 volts, but it does mean that there's power on the output side. I've got the multimeter out set to DC voltage mode, and I'll put my ground lead on TP3. That's the ground test point. I can measure the power supply input voltage on TP1, and that is 8.6 volts. So a little less than what my power supply is set to. And if I come over to TP2, that is the regulator output voltage. This is a 5-volt regulator, and we are indeed getting 5.0 volts. So the power supply section works. We're ready to build the rest of the circuit. Through-hole parts are a little more forgiving. We can mount a few of them at a time now because we can just bend the leads to hold them in place and then do a whole lot of soldering in one go. R1 is 1 meg or 1 meg ohm. R2 if your through-hole part sticks up like that and you don't want it to, you can always just pull the lead to seat it. Oh, but you might go too far. There we go. And I'm bending the leads underneath to keep these in place. D1 is our little signal diode. Just like D2, there is a stripe on D1 to indicate polarity. Match the stripe to the cathode. And C2. While we're here, I'll mount the 555 timer IC as well. It's pretty low profile still. These usually have some splayed leads, so I like to put one side in and then press against it to bring the other side into line, and then press it down. And then I flip the board over and roll out some diagonal pins so that it doesn't shake loose. Go for the easiest pins first because you can always trim them to make room for soldering the others. That joint looks a little bit anemic. For soldering ICs, it's good to alternate the corners that you solder in, so you don't build up too much heat in any one spot. Not a big deal for big old ICs like this 555 timer, but hey, it can be a good trick to keep up your sleeve. I'll rock in the signal pins of the potentiometer and then press gently to convince the larger pins in. You can see me using the cheek of the iron again to get good heat into that pin. This is especially important for these larger pins where I'll heat both the pad and the pin at the same time and then try to feed solder into the interface between the two. The solder can also help to transfer the heat, so it helps to have a little bit on your iron as you start. It increases the contact area. Just letting some of that flux burn out. Beautiful. These headers can be a real pain to get straight. There's a few tricks. You can use a bit of blue tack on unsoldered pins to hold it straight. A little bit more of a gung-ho approach is to hold it by the pin that you're definitely not about to solder. Then you can tin your iron to get a little bit of solder onto it and touch it to one of the pins that you aren't holding. Just to tack it in place. And just like that, we have hopefully a functioning circuit board. I'm soldering on a couple of test points for this next demonstration, where we'll take a look at the signal coming out of the 555 timer. Now we could just plug a servo straight into this and see if it works, but I'm going to do the responsible thing and connect my oscilloscope to TP5. That's the signal output of the signal generator. I've got the circuit powered again by about 9 volts, and the oscilloscope is reading the signal. At one end of travel, we get about 570 microsecond pulse width, and at the other end of travel, we get about 3 millisecond pulse width, which is a little more than about the 2.5 that I was shooting for, but for this servo, it's going to be fine. The important thing to note is that the signal is stable. It's not jittering around as I move the pot. So it looks like we have all the components in the right locations. We haven't swapped any parts. I've increased the current limit on my power supply and connected the servo. My current limit is probably around 1 amp or so. This regulator is only good for about 1 amp anyway. But that's important because I need that current to be able to drive the servo. And you can see as I turn the pot to the right, the servo goes to the right. And as I turn the pot to the left, the servo goes to the left. And I'm getting about that full 180 degrees out of the servo. That's pretty cool. That's pretty cool. We can drive a servo with analog electronics. And so that basically concludes the core content of this course, going from schematic, designing the PCB, getting it manufactured, and assembling hopefully a working PCB. If yours isn't working, you may need to populate a few more test points, maybe check that all the components are the correct values in the correct locations, that all the soldering is good, no shorts, all of those troubleshooting steps. Now, if you want to hone your skills further, check out the other videos we have in this course that have more KiCad workflow tips and some more advanced assembly techniques as well. I'll see you in the other videos.